Hello, everyone. Welcome to this lab. Lab has three parts. Now, let's start the procedure with part one, the determination of the heat capacity of the calorimeter. For this part, you're going to need the calorimeter. This is the calorimeter. You're going to need a clamp to hold or to support the thermometer for this part. The next thing you do is to place 150 milliliter of water in a 400 milliliter beaker and heat it up to 50-60 degree, okay, Celsius. That's what I'm doing now. I have my 150 milliliter water in the beaker on my hot plate now. On the hot plate in 50 and 60 degree, I should be able to start the experiment. So while the water is heating, you have to measure 50 milliliter of cold water in a graduated cylinder and place it in your calorimeter cup. I have my beaker. I'm going to use to get 50 milliliter of cold water. I have my 50 milliliter, okay, water. I place the thermometer inside. Now I'm getting 24 degree. That's the temperature of the cold water, okay? I'm actually getting 24. So I'm gonna pour the 50 milliliter of water inside my calorimeter. And then as soon as I pour it inside the calorimeter, I will cover the top of it. The procedure is asking you to get 50 milliliter of the hot water. I'm going to use another beaker here. Get 50 milliliter. This is what I have. I have 50 milliliter at 55 degree Celsius. Now what I'm going to do is to pour the hot water on the cold water inside my calorimeter. As soon as I pour the hot water inside the calorimeter, I already have 50 milliliter of cold water there. I'm going to add the 50 milliliter of hot water. Okay, that's what I'm doing now. Okay, as soon as it is done, this is what we do. So that series here with my thermometer inside. You need to shield this. You're going to record the temperature for 10 minutes. If over 10 minutes you are not seeing that much change in the temperature of the mixture you have inside the calorimeter, you need to continue till you have at least a change in the temperature. When you start having change in the temperature, you can actually stop. So you're going to need that temperature over time to draw a graph. And that graph will help you to determine the heat capacity of the calorimeter by calculation. Okay, directly from the graph, you will do what we call extrapolation. Extrapolation will give you that final temperature because when you mix the cold water and the hot water, the temperature will go up and then will come down slowly over time. In order to get an accurate final temperature, you need to proceed by extrapolation. This is why you need a graph to get this done. Okay, we're going to proceed to part two. Just like we did in part one, we mix the cold water into hot water. In part two, you're going to mix hydrochloric acid and NaOH. Okay. Before you pour both of those solutions, okay, let's wait a couple of couple of minutes to check the temperature of the two solutions. They have to be about the same before you mix both of them inside your calorimeter to at least move from the same temperature of both solution and record change in temperature over time. So let me check and see. I'm getting here 27. Let me see. This is about 26 here for the other one solution. So they are about the same. Now I can proceed to mix both. Carefully take those thermometer out and actually, always make sure you cleanse those, you dry them. Okay, now I'm going to pour the tubes. I pour them. I close the calorimeter. Okay. Thermometer is seated here for a while now. I can use it to measure the temperature. Okay, you have to record the temperature every 30 seconds for 5 minutes for this part 2 of the lab. Part 3, you're gonna react hydrochloric acid and 0.5 gram of magnesium mercury. What I'm gonna do is to pour my hydrochloric acid inside my calorimeter, and then I'm gonna add the 0.5 gram of magnesium to it. Cover the calorimeter with a lid with the thermometer inside, and then a shield and take the temperature every 30 seconds for 5 minutes. Like I told you for the part 1, if the 5 minutes pass and you are not getting a change in the temperature yet, you can keep going for a while, okay? Because you want to get a good graph. Always you need a graph, a good graph, to do the extrapolation and to get the final temperature. That will help you actually in the calculation part of the lab. So when you're done taking the temperature, you are actually done with this lab. So now that we are done with the lab, we have to proceed to clean up. Okay, always clean up when you're done. Okay.